is designed for unordered collections of photos. It's also slow when applied to video, and in many cases there are failures on aerial video due to some of the particular properties of aerial video. And finally, most of the packages are not really suited, the license model is not really suited for commercial applications. So this is just an example here of a failure with Visual SFM on the same data set I showed a minute ago. An aerial video has particular properties such as temporal ordering of the frames, lots of redundancy between frames, and often when you get up at high altitudes, you have almost planar scenes and narrow fields of view if you're zoomed in to look at some detail. So what is MapTK? MapTK is the Motion-Imagery Aerial Photogrammetry Toolkit. It's structured for motion optimized for aerial video. It's open source. It's permissively licensed with a BSD license. You can get the code and download binaries on GitHub. It's cross-platform, Windows, Linux, Mac. It's extensible. It's plugin based, and we have plugins written for the series solver, for OpenCV, for VXL, so you can plug in those algorithm pieces into this and run it. It's highly configurable at runtime. You can configure it with configuration files to tune whatever parameters you want to change the algorithms that are running. It's visual. There's a graphical user interface on top of it. It's written in C++ with C and Python bindings in development. And this has been developed and technical support is provided by Kitware with active funding from the US Air Force. And furthermore, this is a component of what Kitware calls Quiver, which is a larger selection of Kitware open source tools. So there are a few key algorithmic advances that I'm not going to go into the details here, but you can come talk to me at the poster. One of them is temporally hierarchical SFM, which is useful for high frame rate video, where you don't need to reconstruct every frame of the video. You downsample temporally, get a solution, then go back and fill it in to get the missing frames. The other is a homography-driven loop closure, because often when you have high altitudes and the ground is planar, you can map all the frames into a common plane and use that to detect when you revisited the same location and use that to trigger loop closures. So I mentioned before that we have a GUI as well. The GUI allows you to play back the video. So unlike other GUIs, this one's more video-based than image-based. There's options to turn on and off visualizations of different things. I'll show a little preview of that here. So this is not running real time. This is an offline system, but we're loading in the results. And you can interact with the system, see what the results look like, look at reprojection errors, and sort of introspect the data in any way that you like. So the poster session it's D3, so please come visit me to learn more. D3 is just 3D backwards, so you can remember that easily. Thank you.